All right, so today we're going to talk about properties of definite integrals. And if you read these directions, it says to write what you think each is equivalent to. And then it talks about being prepared to explain this reasoning with the rest of your class. So I guess they don't understand that we're under quarantine right now. But I do want you to just pause this video for a second and go ahead and write out what you think these might equal. So pause, write, and then come back to me. Under here so I can write on it. Oh, sorry. Okay, so remember, this is the antiderivative. Derivative. I just crossed the D. Of little f of x, okay? So the antiderivative from a to a. Well, did you go anywhere? That would be the antiderivative of a minus the antiderivative of a, which would be 0. Okay, and then it has one where like c is between a and b. So you've got from a to b, and then there's some c between there. Well, that would equal antiderivative from a to c of f of x dx plus antiderivative of c to b of f of x dx. You just split that up right there. All right, so if the definite integral from a to b of f of x dx equals k, then the definite integral from b to a would equal what? Think about that. What did I do? I just went like this is a subtraction problem, basically. So if from a to b equaled k, if a minus b equals k, then b minus a is going to equal negative k. Because from a to b, f of x dx equals f of b minus f of a. But if you go from b to a of f of x dx, then that would be f of a minus f of b. Given that b is less than a, so if you go from a to b, but b is the smaller number, and it's going to equal the negative of b to a f of x dx. If k is a constant, we actually did this one yesterday with that chart, table, whatever. We did this one. You can take that constant out and you just do k times from a to b of f of x dx. And then number 6, we kind of did this one too yesterday with that table. That would just be from a to b of f of x dx plus or minus, whatever it is, from a to b of g of x dx. All right, and then if you have an even function, if f of x is an even function and you're going from, like, let's say negative a to a, it's even. So these two spaces are exactly the same from here to here. But if I go all the way from negative a to a, that's going to end up looking like it's 0 because this is going to be a negative area, this is going to be a positive area. But this is the exact same as that. So you could just say 2 times 0 to a f of x dx. Or you could say 2 times from 0, I'll put that on the wrong side, 0 to a, negative a, my bad. But if it's an odd function, from negative a to a, it's above, it's below, it's going to be 0. So that one's actually not going to be 0. I just made that up. Just kidding. But it's 2 times. It's the same. But if it's an odd, one's above and one's below. That's not 0. I take back everything I just said. All right. I don't know why I'm waiting on you to write, because you could just pause it if you need to write. Okay, let's look at this side. So if the definite integral from 0 to 3 of f of x dx is 6, and the definite integral from 3 to 7 of f of x dx is negative 8, then we're going to try to figure out the value of each of these using those properties that we just had, okay? So first of all, we know from 0 to 3, but we don't know from 3 to 0, except that we do because it equals the negative of 0 to 3 f of x dx. That's one of those properties. So if from 0 to 3 is 6, from 3 to 0 is going to be negative 6. All right, this one goes all the way from 0 to 7. Well, I don't have 0 to 7, but I have 0 to 3 and I have 3 to 7. So I'm going to use that property, the one with the C in the middle. This one right here, number 2. I'm going to use that one. I'm going to say, okay, well, this is going to be equal to the definite integral from 0 to 3 of f of x dx plus the definite integral from 3 to 7 of f of x dx, which that one's 6 and that one's negative 8. So all together now, it would be negative 2. If I go from 3 to 3, well, if you go from the same to the same, it's going to be 0. So, I said explain it, so we'll explain it. Equals 0, where f of x is the antiderivative of f of x. All right. Okay, so from 7 to 3 of 3 f of x dx. So we've actually combined a couple of them. So we're not going from 7 to 3. We're going from 3 to 7. And it's being multiplied by 3. So it's going to be a negative 3 times 3 to 7 f of x dx. So it's going to be a negative 3 times a negative 8, which is 24. Okay, let's look at this one. From 3 to 7 of 2 dx plus 3 to 7 of 3 f of x dx. All right, so this one I don't have, this is f of x. Like, I know what that one is. But see, this I don't know. So this is going to be 2x from 3 to 7 plus 3 times a definite integral from 3 to 7 of f of x dx. So I need you to pay attention. These are not the same. This is f of x, which was given to me in the directions. This is just the antiderivative of 2 dx from 3 to 7. I don't know this one. Now you're like, well, we got 3 to 7 up there. But we have 3 to 7 of f of x. That's not f of x. So this is going to be 2 times 7 minus 2 times 3 plus 3 times negative 8. Where'd you get the negative 8? Right up there. That in the directions will tell me that equals negative 8. So that's 14 minus 6 minus 24 for a grand total of negative 16. Okay, let's look at this one. All right, it says if f of x is an even function. So we're just going to do, because we don't have negative 3 to 3, but it's an even function. So I know what 0 to 3 is, and I can just double it. So that's going to be 2 times 6, so it's 12. And then if it's an odd function, then I can do negative 3 to 0 of f of x dx plus 0 to 3 of f of x dx. So this is that like a negative rule, so it's going to be negative 6 plus 6, which is 0. Look, he gave us a break. He gave us this empty rectangle right here. I can't believe it. He actually left an open space. What is life? All right, so let's look at this shape here. Let me get my next page out. All right, so we have a portion of a continuous function f of x right here. Okay, and we want to know what is the value of the definite integral from 0 to 3 of f of x dx. Okay, so first of all, let's look at all the shapes we have here. All right, you have this portion right here. This is a semicircle. Got a semicircle going on right there. And then right here, I've got a rectangle. Here on the ends, I have some triangles. I got triangles down here too. I mean, if you really think about it, there's some triangles right there. So there's a lot of shapes going on right here. But I want to go from 0 to 3. So from 0 to 3. All right, so right here, that's a fourth of a circle, right? Because it's half of half, that's 1/4. So that's going to be 1/4 pi r squared. So from here to here, r is 2. All right, plus, since I have to go to 3, I'm just going to do a trapezoid instead of doing a rectangle added with a triangle, because that's a trapezoid. So that's 1/2 times the height, which is 1, times base 1 plus base 2. So let's see, that's going to cancel out. So it's going to be pi plus 2.5. That's my area right there. What's the value of the definite integral from 0 to 3 of f of x dx? Pi plus 2.5. All right, if I go from 0 to 4, okay, well, these two right here, these two are the exact same size. So they're going to cancel each other out. See that one and that one? Because that's going to be a positive and that's going to be a negative. And we've already figured out that the area of that quarter circle is pi, right? Do we need to do the 1/4 pi r squared again? It's the same. It's right there. Plus just the rectangle, which is 2 by 1. So that area is pi plus 2. All right, from negative 3 to 3. From negative 3 to positive 3. Well, now we have a half of a circle. So it's going to be 1/2 pi times r squared plus you've got a trapezoid here. I'm sorry, I was trying to count it out. There's a trapezoid right there with a height of 1, base 1, 1, 2, 3, 4, 5, 6. 1, 2, base 4 is 4. Okay, so that's going to be 2 pi plus, that's 10, 5. Okay, now got some algebra with the calculus. Remember calculus? It's the algebra that kills you. Prepare to die. Okay, so if f of 0 is 5, what's the value of f of 3, where f is the antiderivative of f of x? Okay, so we're going to go from, like they've mentioned 0 and they mentioned 3. So we're going to go from 0 to 3 of f of x dx, because that would equal f of 3 minus f of 0. And I'm trying to find f of 3, and I know f of 0. And I know this because I found it on the very first problem on this page, right? I know that this is pi plus 2.5. I don't know f of 3, but I know that f of 0 is 5. Oops, minus. Add 5, add 5. Pi plus 7.5 would equal f of 3. Okay, so we're going to go over to this one. Now, it says if f of negative 2 is negative 2, what's the value of f of 2, where f is the antiderivative? Okay, so actually I don't have this one found already, so I'm going to have to find it, but I'm going to go from negative 2 to 2 of f of x dx, because that would equal f of 2 minus f of negative 2. All right, so from negative 2 to 2 is just that half of a circle, which we found that already. That was 2 pi, plus the rectangle, which is a 4 by 1. And that would equal f of 2 minus what? Negative 2. Okay, so you've got 2 pi plus 4 equals f of 2 plus 2. Minus 2, minus 2. 2 pi plus 2 equals f of 2. So there you go. All right, so I think we've got free response to do together, maybe? We're supposed to do this one together? I don't know, let me look. Day 55, 1 through 12, 4 and 5 more 2. Yeah, we'll do this one together. Okay. All right. So we have f is a continuous function from negative 3 to 4, with f of 0 equaling 3. That's going to be important, I feel like. And we have the graph of f prime right here. The derivative consists of one line segment and a semicircle. On what intervals, if any, is f increasing? Justify your reasoning. Okay, if I'm asking where f is increasing, then on f prime, I need to be looking at if it's greater than or equal to, no, sorry, just greater than 0. Where is it above the x-axis? And that's happening from negative 3 to negative 2. So, f of x is increasing on negative 3, negative 2, because f prime of x is greater than 0 on that interval. All right, next question. Find the x-coordinate of each point of inflection of the graph of f on the open interval from -3 to 4. Justify your answer. So if we're looking for inflection points, then we actually need f double prime. Okay? So we have an inflection point when f double prime changes signs. So if f double prime is changing signs, that means f prime has a relative max or relative min. So that's going to happen at x equals 0 and x equals 2. So f of x has an inflection point when f double prime changes signs. So if f double prime of x changes signs, then f prime has a relative max or min. Has a relative max or min, which occurs at x equals 0 and x equals 2. All right, find the equation for the tangent line to the graph at the point 0, 3. All right, so you need a pot and a sot. Oh, they gave us a pot. F of 0 equals 3. F prime of 0 is -2. So that would be y minus 3 equals -2 times x minus 0. All right, find f of -3 and f of 4. Show the work that leads to your answer. Okay, so we know f of 0. So, but we need f of -3. So what we can do is we can go from -3 to 0, f prime of x dx, because that would equal f of 0 minus f of -3. So this, from here to here, from -3 to 0, you've got a triangle. So that's 1/2, 1 times 1. And then you have another triangle. It's negative. And it's 2 by 2 equals, we know f of 0, it's 3. Minus f of -3. All right, so that's 1/2 minus 2. We'll go ahead and move that over. Minus 3 equals a negative f of -3. It's -4.5. It's -9/2 equals a negative f of -3, or f of -3 equals 9/2. Okay, so then we have to find f of 4. I'm going to do the same thing, except I'm going to go from 0 to 4. So I'm going to use what I know. F prime of x dx would equal f of 4 minus f of 0. Okay, so this right here, I've got to find the area from 0 to 4. Okay, so what I'm going to do to find that area is basically I'm going to find the area of this rectangle, and I'm going to subtract out that semicircle. Okay, can you see there's a rectangle right here? And what I'm actually trying to find the area for is this and this. Looks like a bridge. Okay, so I don't need this tunnel part. So I'm going to find the whole rectangle and I'm going to subtract the tunnel. And that's going to leave me with those two bridge supports, right? So the rectangle is 4 by 2. And then the circle is 1/2 pi r squared. Now, one other thing, this is below the x-axis, so it's negative. And that equals f of 4 minus 3. So I'm looking at a negative 8 minus 2 pi equals f of 4, little f, it's kind of a big deal, minus 3. So that's going to be a negative 8 plus 2 pi plus 3 equals f of 4. So f of 4 equals 2 pi minus 5. And there you go. All right, it's homework time. Day 56, homework. All right, enjoy.